Hi, in this video we're taking a look at 2018 Ordinary Level Maths Paper 2, Question 7. It's a statistics question. Let's get right into it. The table below shows the total rainfall in millimeters and total sunshine in hours at Valencia County, Kerry during months of June from 2001 to 2010. Based on the data in the table, we have to write down the range of the rainfall data. So looking at rainfall, I'm going to find the highest value, which is 140, not 149, actually that's 155 in this particular case. So that's the highest value. And I'm also going to find the lowest value, which is equal to 47. Range is the difference between maximum and minimum. So 155 minus 47 equals to 108 millimeters. So that's done. The year with the highest June rainfall is 2003, because we already found that maximum value is 155, and that happens in 2003. And the year with least sunshine in June, so we have to look at the total sunshine in a row, and looking at the row, the column with the lowest value, I'm noticing that it's 2002, where the total sunshine was only 120 hours, so 2002. Then, based on the data in the table, we have to write down the year with best June weather and give a reason for our answer. So what I'm looking for is the year with maximum amount of sunshine and the least amount of rainfall. So least amount of rainfall occurs in 2006. 47, and I'm also noticing that it has quite a significant amount of, it's actually the highest amount of sunshine as well. So I can clearly say that 2006 is the year, and that's because it has most sunshine hours and least rainfall. So then the next thing to do is to write rainfall data in increasing order and then find the median of the rainfall. So in an increasing order, I'm going to start with the lowest. So the lowest rainfall is 47. Cross it out. Go to 72. Cross it out. Crossing out means that I will not write a value again. Then the next value is 84. And I'm going to continue that through 94 once, 94 two times. The next value is 101. Following that, we have 133. After that, 134. And finally, 149. And 155. So these are my values in increasing order. Now I'm going to find the median. The procedure, the simple way of doing it is to go from each end, crossing out each values to find what's the middle value. So I'm noticing that I have two values in the middle. I can't have a single value for a median. So median will be found by adding 94 plus 101. And dividing it by 2. So when I do that, I'm going to get that median rainfall in June is 97.5 millimeters. In the next part of the problem, we have to find the mean number of sunshine hours for June in Valencia. So mean is the sum of the sunshine hours divided by the number of data points. So the mean, if I wanted to write this out, would be 169 plus 124 plus 180 plus 173 plus 173 plus 239 plus 159 plus 168 plus 228 and then plus 205, all that divided by 10. And if I do the calculation, I'm going to end up with an expression of 1818 divided by 10, and that's 181.8 hours. In the next question, we have to find for what years was the sunshine was the sunshine data within 5% of the mean number of sunshine. So I know that my mean, calculated in the previous part, is 181.8, and that means that 5% of mean is 5% of 181, and that is equal to 9.09. So plus 5% is 181.8 plus 9.09, and that is equal to 190.89, minus 5% is 181.8 minus 9.09, which leaves me with 172.71. So these are values of within 5% of mean. So any values in this range between 172 to 190.89 should be included. So looking at the data with sunshine values between 172 and 190, let's look at the table. 172, so 2004 shows up, 2005 shows up, also 2003, and no other data points. So my answer should include those 3 years, 2003, 2004, and 2005, and I can highlight this as my answer. So standard deviation data correct to 1 decimal place is best found on a calculator. So making sure that you're in your statistics mode, enter the value into the table, the value for the rainfall data, and then you can come out from the table and go into the statistical parameters and find the standard deviation by clicking a button that looks like this symbol, and you'll find the standard deviation is equal to 33.4605. Correct to 1 decimal place, we have to round up to 1 decimal place, and we're rounding up because the second decimal place is more than 5, so standard deviation is 33.5. In the next point, we have to plot the scatter plot of the data in the table shown below for the total sunshine hours and total rainfall. So I'm just going to do a quick copy of the table so I can use it as basis for my plot. Using the table, let's start with in the first column. So the first 4 data points are plotted, and you can see we have 72 is over here with 169 for the first point. So we can skip the first 4 because these are already done. And let's start with 94 and 173. So we're looking for 94 along the horizontal and 173 along the vertical, somewhere along here. So let me just increase the size of the point that I'm going to be making, and let's start plotting. 94, 173, I'm guessing somewhere over here is a reasonable place to put this point. 47, 239, 40 along the horizontal, and 239, so somewhere over here. 149, 159, 149, 159, somewhere over here. 134, 168, so something along this direction. And then 94, 228. 94, 228 is going to be about here. And then last but not least, we have 84 and 205. 84 and 205 about here, let's say. So we have our plot, and now we have to tick a box to figure out one of the numbers in the table on the right is the correlation coefficient for the data plot, correct to 1 decimal place. Based on the scatter plot, select the number that you think most accurately reflects the data. So looking at the data is negative, and you could imagine being able to fit a straight line that goes through those data points. So I would say it's definitely a negative correlation, so it has to be either -0.1 or 0.6, and looking at the fact that you can fit a straight line here, 0.6 is good. And explanation, you say that correlation is negative. And you can mention that there is a strong correlation. And that's the end of this problem. So it's a good place